In this lecture, we are going to discuss about singularities of analytic function. Singularities of analytic function is a point at which the function fails to be analytic. Next is proper definition of analytic singularities of analytic function. Definition: if a function f(z) is analytic in a bounded domain except at a finite number of points, then these exceptional points are called singularity or singular point, singularity or singular point of the function f(z). Next is type of singularities. First is isolated singularity of a function f(z). Isolated singularity a point z equal to a is said to be isolated singularity or singular point if the function f(z) is analytic at every point of the dilated neighborhood, of delta neighborhood, not dilated neighborhood, delta neighborhood of the point A other than A itself. That means it is analytic at delta neighborhood but not at A, then it is called isolated singularity of the function f(z) or except at A. For example, consider the function f(z) equal to 1 by z square minus 9. Then singularity of the function f(z) is obtained by finding the point for which the function f(z) is not defined. For that, you should equate the denominator to 0. This function is not defined when this denominator will be 0. So this is equal to z equal to plus minus 3. Here z equal to plus minus 3 is the isolated singularity because the function is analytic at every the given function the given function fz is analytic at every point of every point of the delta neighborhood, or at every point of the of delta neighborhood at every point in the at every point in the delta neighborhood of plus minus 3. Therefore plus minus 3 is an isolated singularity or singular point of the given function f. Singularity or singular point of the function f. Okay. Second is non-isolated singularity. Singularity or singular point. A point z equal to a point z equal to is said to be non-isolated singular point of fz if every neighborhood of a contains singularity of fz other than a. Contains some other singular point, contains some other singular point of fz other than a. Okay, that means if fz contains singular point other than a, then it is called non-isolated singularity. That is, within the delta neighborhood of z equal to a, we will get some more other singular point of fz, then it is called non-isolated singular point. Okay, next is example. Consider fz equal to 1 by 10 pi by z, which can be written as 1 by sine pi by z by cos pi by z, and this is equal to cos pi by z will go to numerator and sine pi by z will be in the denominator. Therefore singularities of fz are obtained by equating denominator to 0, that is sine pi by z is equal to 0, and we know that sine pi by z is 0 when sine is pi. Okay, when sine is pi, but sine is a periodic function, so with period n pi, so after every n pi it will be 0, where n belongs to my set of real number. Okay, so this implies pi by z is equal to n pi. this is equal to 1 by z is equal to n. This implies z is equal to 1 by n. Here you can check it out for when the singular point of the function fz are 1, 1 by 2, 1 by 3, 1 by 4, it is accumulated near 0. So 0 is the singular point of fz which contain no. So right, 0 is the here 0 is the singularity of fz, singularity of fz, fz, and every neighborhood of 0 contains singularity singularities of fz other than 0. Okay, other than 0, therefore 0 is my 0 is non-isolated. Okay, 0 is non-isolated singularity, non-isolated singularity of fz. With that, I would like to conclude. Remaining will be in the next lecture. Thank you.